Hello everyone, in this video I'll be solving the problem BST with dead end, and this problem is from geeksforgeeks. And the problem states you are given a binary search tree which is BST. I think most of you know what is BST. So BST is basically from the let's say we have a root node. The left child has to be lesser than the root node, and the right child has to be lesser than or equal to the root node. And if left child in turn has some of the child that has to this condition whatever right now I've said has to hold for all the subtrees as well basically. So we are given a binary search tree containing unique positive integers given greater than 0. Your task is to determine whether the BST contains a dead end or not. So okay, we have given a BST and node values are unique. We don't have any repeated value. That is one thing, and all the values are greater than 0, which means we have value from 1 till int max, you can say. And we'll have to find a dead end. So what is dead end? Let's try to understand. Note, dead end is a leaf node. Okay, it is a leaf node, not any internal node. It is a leaf node in the BST such that no new node can be inserted in the BST at or below this node while maintaining the BST property and the constraint that our node value must be greater than 0. Okay, let me take you to the board what they're saying, and then let's try to break down the problem. So dead node is defined as it is a leaf node. Leaf node, you can say we can take 1 7, and here we have 9 3 9. So these three are the leaf nodes, and from here if you are not able to assign any value, okay, so then that is a leaf node. If you take one, if you see one's smaller value will be, I mean, left side if you take that will be smaller value, so the value will start from 0 0, and we can take int minimum values. And if we take right side, we can take value from 2 to int max, but int max is not the case here because it is coming from 2, so the right side's value is constrained to 1 only. So if you see uh, this value will be like from 2 to 1 you can take. So actually if you see from 2 you cannot take any node and put any value. Okay, so 3 you can't take here. Why you can't take 3? Meaning, say it is came from 2. Since binary search tree, let's say 8 we have here. So if left child is less and it's 2 is less than 5, so we will come here. Whenever we come at this point and we want to insert 3, it will go to this location, not here it will go. Because if you place it here, so this will not hold the binary search tree property. Why it will not hold? Because these 3 hash will be on the right side of 2. Okay, it shouldn't be on the left side. So if you want to go to 3 from 2, you will have to go to left side, which is false. So you cannot insert anything. So in this case we have a dead node. Now let's say you have a 7 here. So what node can be inserted? You can insert 6 as well here, because that will hold the BST property. 8 5 less than 8 will come here, 7 is less than greater than 5 will come at this point, and we can insert 6 here. Also we can insert if you want to insert, let's say 4 will come here at this point here. 4 you can insert here. So basically one value you can insert at this point, 6 that was there, so it is not in that now. If you take 9, so um, 9 is greater than 8, so it is right side. Left side, if you want to insert anything, you can't insert because BST has all the unique values, and left side means it should be lesser than 9, which is from 8. But 8 is there already, so you cannot insert. But right side, you can insert any value from 10 to int max. Any value can be inserted. So this is also not a dead node. So I think you got what is the meaning of dead node. Now let's try to break down the problem. So your idea is what will be doing. One thing is that, see, whatever values we have at this point, so since in question I have said the value will start from greater than 0, which is 1, and it can go to int max. So this is our range basically. Okay, in this range only all the node values will be there. So when you are at 8, so it has a left child now. So at 8 what I'll do is I'll insert its bound to 1 comma int max. This is our left and right range. Whenever we are calling the left child, in that case, since we are going to left, so this right range will be decreased. Okay, so the values should be from 1 to 7. As you can see, left side we are going, so BST property is all the node value on the left side has to be lesser than this 8 value. So if you see, if you're calling at this point, so our range will be 1 to 7. I think you got how it is 1 to 7 because we are starting with 1, greater than 0 left side, so we are starting with 1. So and the right range will be lesser than this, so 1 lesser than this. So we have a range of value. And if you go again left side, so our value will be left range is 1 only, but right range will be decreased by 1 again from this value, which is 4. So all the values in this tree has to be in the range 1 to 4. Okay. Now if you call the left side again, so you get at a point where left is 1, right will be lesser than this, 2 minus 1 is 1. So if you see, we have a range from 1 to 1 only. In this case, if you see, we have a choice, like from 1 to int max is a choice for this node. For this node, if you see, it has a choice from 1 to 7. So 1 to 7 means 1, 2, 3, 4, 5, 6, 7. So its value is 5 now. It has many choices. Okay. If you see 1 to 7 is there. 1 to 7 is there. But it has left with 3 more choices. So this node has got a choice now. It can choose 3, 4, 5 as well, okay, from this node. So it is not treated as dead node. Now if you come to this position, so it has a choice from 1 to 4. 1, 2, 3, 4, and its value is 2, and it doesn't have any right children, it has left children, it is having value of 2, and it has got with a choice of 3 and 4, so it can insert either 3 or 4. So it is not a dead node, so it has a choice. It can be from this node we can derive one of the node whose value will be 3 or 4. So it has a choice. And if you try to see for this one, 1 comma 1, we have a node 1 and its range is also 1 only, and we don't have any choice. We don't have like any value can be inserted at its below, so we don't have choice. So once we don't have any choice, so in that case this can be treated as dead node. I think you got what I'm trying to say. So now we have got a one dead node. Once we get a dead node, we will be returning true. And once we find here we have a dead node in this, so we will be simply returning true. We don't go to the right side and check. In this case also we don't go on right side and check. So for sake of explanation, I will be going to the right side. So see, at this point we have a range from 1 to 7, and so right side means the range left range will increase by 1, so it will be 5 plus 1, which is 6. Why 5 6? Because it is a BST, so right children has to be greater than this node values, and left range, since it is bound to 7 from the up, so it will be 7 only. So if you see for this node, we have a range 6, 7, and this node value is 6, and we are left with one choice. So we can insert 1 6 node at this position. So it has got a choice, so it is not a dead node. Even though here we have got a dead node, we will be simply returning true. But for sake of explanation, I am showing how it works. So yeah, pretty much that's it. Now 6, 7. Now let's say we are going to the right side. So right side means left range will be increased by 1, which is 8 plus 1 is 9. So left range is bonded to 9, but right range it can be your value from 9 to 8 max. So this has got a value from 9, 10, 11 up to so on 8 max, basically infinity. So it has got these values. So we have 9 at this position, and these are some of the choices that can be made. We can insert 10 here, we can insert 11, we can insert 12. So many values we can insert. So it has got a choice. So one of the node we can derive from this. So hence it is not a dead node. So in this tree, if you see, we have only one dead node, and once we got this node, we will be returning true. Let's try to understand the second problem. This is easy indeed. I mean, we'll have to just find the range. Second problem is 8, 7, 2. 10, 9, 13. So starting what values the range will be from 1 to int max. As per the question, like the value has to be greater than 0, so we'll start from 1 and it can go to any value till int max. And when we're calling the left side, so our left range will be same thing only, right range will be going to roots value minus 1, this will be 7. So if you see at this for this node, we have 1, 2, 3, 4, 5, 6, 7, these values. And below this node, like if it is this 7 is done, but below this we have only 2, and we are left with like 5 choices. So we can insert any value. Let's say we can insert here, not here, here we can't insert, but we can, it can be inserted, 1 can be inserted here, 3 can be inserted here. So there are many choices for this node. So that is not a dead node. And if you come at this point, so left range will be this, the right range will be decreased by 1 node value, which is 6. So now this is a leaf node, and here we have to consider a dead node. So 1, 2, 3, 4, 5, 6. Root node is 2, and it has got so many of choices. So this is 2. So left side we can insert 1, right side we can insert this any values. So it has got a choice. So it is not a dead node now. Let's consider now 10th one. So left range will be increased by 1 because we are going to the right side. So 8 plus 1 is 9 basically, and then here it will be int max. This is the range. Now again, in this position, if you say 9 to int max, let's say 14 is the value which is not present here, which can be inserted here. So it is not a dead node. In question they have asked dead node will be only at the leaf node. So we are not worried of these things. Yeah, now let's come to this one. I'll explain to you that how to identify dead node at the leaf. So left range will be, since we are going to the left side, left range will be as it is, but right range will be increased to, decreased to 1 by the root value, which will be 9. So in this case, if you see, left range, right range, and root value all are equal. So in this case, this is a dead node. We cannot have any values apart from this 9. Any values that can be put in to the left side or right side. We cannot have derive any node from this. So this is a dead node. Since we have a dead node, we will be returning true. Okay. So whenever you go to the leaf node, you have to find left, right, and node value. If all three are equal, so in that case, that is a dead node. Now let's come to this side. So left range will be 11, right will be int max. So if you see from 11, 12, 13, 14 till infinity, we have many values. So 13 is here. We can have any values. Left side we can have 11, 12. Right side we can have from 14 to int max any values. So it has a choice which can be, let's say 11. We can have a node whose value is 11 left side, or we can have a node, let's say 14, which is on right side. So it has a choice. From this node we can derive node. So this is not a dead node. So if any dead node is there, so we will have to return true. So problem statement, you got it. Let's try to code it up. So as you saw in the board, it was a simple condition. So we'll take one helper function. We'll send root, and for the root, our range will be from 1 to int max. Okay. We'll take one private function whose return type is boolean, since we're running true or false, and its name is helper. we are sending root, we are sending left range, we'll say left range, we are sending right range. Okay, if let's say root equals to null, root null means we'll have to return false, meaning root null means, let's say somehow we came out of the loop. Let's say we have one here. I mean, one of the case was like, let me take example from this only, 872. 872. Here it was 10, 9, and then 13. So if you come to the root, so here it was range like 1 to 6. Okay, so you'll call the left function, that whose value will be from 1 to this minus 1, which is 1. So this is basically root node. So in that case we'll have to return false, because we are not having any dead node. Root when we are going to out of the, I mean whenever we encounter null values, so in that case, which means this is not a dead node, so we have came here, so we'll have to return false in that case. So we have got here. Now we'll have to check one condition here. If left range equals to root of data and root of data equals to right range, which means all the three values are equal. So in this case we have found a dead node, we'll have to return true. Else we'll have to check if helper, we're calling for the left side, root of left, we're going to left, so left range will be as it is, but right range will be decreased by root value by 1. So why I'm writing if condition, if from the left side we have got a true, so in that case we'll have to return true. Else we'll have to return, we'll have to go to the right side, and right side whatever value we'll get, we'll have to just return. We are going to the right side, and since you are going on the right side, so its left range will be root value plus 1, and right range will be as it is. Let's try to run the code. Line number 22, left. What is happening here? Acha, value is not there. Okay, root of not value, it is data. Here also we have data. In lead code it will be value, so I've got used to it. So yeah, it is running fine. Let's try to submit the code. It got accepted. Now let's try to analyze the time complexity of this algorithm. So we are going from helper function, we are going to this let's say function. We are going to every node once. Okay, every node. So its time complexity is O of n, and space complexity will be height of the tree. In case of skew tree, it will be O of n only, but in case of unskew tree or complete tree, binary search tree. So in that case, since it is a binary search tree, skew tree is very hard in this case. So space complexity will be O of log n. So yeah, thank you guys for watching the video.